In the last class, we have discussed about, you're there, right? What we were discussing? Asset basis. ಆಯ್ತಾ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ ಓಕೆ ಗುಡ್ ಮಾರ್ನಿಂಗ್ ಓಕೆ today I will discuss few topics: hydrocarbons, carbon and its compounds, important synthetic materials, etc. today. Then tomorrow we'll have a basic introduction class kind of thing for the preliminary examination, where we will be discussing about the complete UPSC CSA examination pattern. Later, do you know the pattern of the examination? You'll be knowing it will be having preliminary, mains, and the interview or personality test, right? But do you know the cutoff marks, then minimum eligibility in few subjects, right? Do you know these things? Okay, we'll discuss tomorrow. Later, we'll discuss at least 3, 4, 5 years preliminary examination, science questions. Then later we'll start with the technology part, right? Okay. Hydrocarbons. Have you heard the name? Hydrocarbons. Carbohydrates. You have heard, right? Carbohydrates, proteins, vitamins, minerals, etc. Carbohydrates are which type of nutrient? Bodybuilding nutrient, protective nutrient, or energy giving nutrient? Carbohydrate, energy giving nutrient. Carbohydrates and fats are energy giving nutrient. Carbohydrates are made up of carbon, hydrogen, and oxygen, right? Here, hydrocarbons are made up of only carbon and hydrogen elements. It's a compound of carbon and hydrogen. Hydrocarbon. In daily life, few examples of hydrocarbons. We do use liquefied petroleum gas, LPG, at our home, right? That is hydrocarbon, propane plus butane. Then cigarette lighter, the liquid, the gas present inside. The gas is present in the liquid form inside that lighter. That is butane. Then naphthalene ball, we do use at our home, right? Naphthalene ball. That is also hydrocarbon. Then gas welding machine, gas welding. There we use acetylene, hydrocarbon. Likewise, there are so many hydrocarbons. How many types of hydrocarbons are classified into? Generally, 2, 3, 4. The first thing which comes to our mind when we talk about hydrocarbons is, if you know, alkane, alkene, alkyne. But there is a bigger sub classification. Hydrocarbons are classified into aliphatic hydrocarbon, then aromatic hydrocarbon. Aroma means aroma. Aroma means smell, but here it is not smell. Aromaticity is a property where the electrons will vibrate, fluctuate, and change their place by electron. It will be having that property, that is aromaticity here. Aliphatic and aromatic hydrocarbon. Under these two, we can subclassify them as saturated hydrocarbon and unsaturated hydrocarbon, saturated and unsaturated. Aromatic hydrocarbons generally are unsaturated hydrocarbon. They can also be called as cyclic hydrocarbons. These can also be called as acyclic hydrocarbon. Acyclic. Saturated means generally the term saturated. In an examination, SSC examination, they have asked solubility of sugar in water is dash compared to salt. Solubility of sugar in water is dash compared to salt. More, less, same, none. What do you say? That means in this 1 liter of water, when compared to the solubility, dissolving ability of sugar and salt, which is more, which will dissolve more, salt or sugar? Generally, we know the case of the sea, where more amount of salts are dissolved. That's why we say salt will dissolve more. Actually, that is not the case. When you practically test, you will get to know sugar will dissolve more in the given quantity of water when compared to salt. Solubility of sugar is more compared to salt. Solubility is more. Let's say for a glass of water, we can add 5 spoons of sugar. That 5 spoons of sugar will dissolve completely. That is saturated. It can dissolve that amount of sugar in it. Okay. If you add 15 spoons of sugar, what will happen? How many times you may stir, it will not dissolve. The sugar present in the water will not dissolve because it is more than the limit the water can dissolve. The saturation level exceeded. That solution will become unsaturated now. How can you increase the solubility of sugar in water or any salt in water? By heating, you can. If you heat, more sugar will dissolve in that water, right? Upon heating, we can increase the saturation level. That is saturation level regarding the soluble salts or sugars. Here, the saturation level means carbon can create one single carbon atom can create 4 single bonds. How many? 4 single bonds. Hydrogen can create only one single bond. Hydrogen can create one single bond. Carbon can create 4 single bond. If the compound, if the compound has only single bonds, then it will be called as saturated. If there are any double or triple bonds, then it will be called as unsaturated. Only single bond, saturated. Double, triple bond, unsaturated. 4 bonds cannot be formed. Maximum 3 triple bond can be formed. Saturated hydrocarbon. Example of saturated hydrocarbon is alkane. Alkane. Unsaturated hydrocarbon, alkene and alkyne. Alkene and alkyne are unsaturated hydrocarbons. Alkane, alkene, alkyne, saturated and those two are unsaturated hydrocarbons. Alkane, saturated hydrocarbon, only single bond is present. The formula CnH2n plus 2. CnH2n plus 2. Alkane. Alkene. CnH2n. That's it. Alkyne. CnH2n minus 2. CnH2n minus 2. If n is equals to 1, if n is equals to 2, if n is equals to 1, CH4, right? 2 ones are 2 plus 2, 4. C1H4, nothing but CH4. This is the simplest hydrocarbon. CH4, simplest hydrocarbon among all. CH4. CH4 means methane. Methane. Have you heard the name methane? It is present in biogas, methane, gobar gas, methane, natural gas, methane, CNG, compressed natural gas, nothing but methane. Then in the marshy land, methane gas will be released. Then in the paddy fields, paddy, bata, there also methane gas is released. CH4 methane, simplest hydrocarbon. Okay. N is equals to 2 means C2 H 2 2s are 4. 4 plus 2 6. Okay, C2H6. Here CH4 1 carbon 4 hydrogen single bond saturated hydrocarbon C2H6 C2H6 2 carbon 1 2 3 1 2 3. Hydrogen can form only single bond. 6 hydrogen molecules are there, atoms are there, then 2 carbon atom. Only single bond is present, right? Carbon carbon single bond, so it is saturated hydrocarbon. Then alkene. Let's say N is equals to 2. We will get C2H 2 2s are 4. C2H4, right? Here carbon H4. Between carbon and carbon there should be a double bond so that 4 bonds will complete, right? Carbon carbon double bond here. This is C2H4. Alkene double bond is an unsaturated hydrocarbon. Alkene double bond unsaturated. Then if here N is equals to 2, N is equals to 2, N is equals to 3. N is equals to 2 means C2H 2 2s are 4, 4 minus 2, 2. C3H 3 2s are 6, 6 minus 2, 4, right? Carbon hydrogen, how much? Only 2 hydrogen. Carbon triple bond. Unsaturated hydrocarbon. Alkyne triple bond unsaturated hydrocarbon. See, carbon can form how many bonds? 4. Here 1 2 3 4. This one 1 2 3 4. All are single bond. Here 1 2 3 4, all are single bond. Here one with hydrogen, one more with hydrogen, then no more hydrogen are present for this carbon atom. That's why it is forming a double bond with the other carbon atom. So total 1, 2, 3, 4, 4 bonds are there, right? Likewise for this carbon atom, 1, 2, 3, 4. For this carbon atom, 1 with hydrogen, 3 with carbon, right? Carbon carbon triple bond. C3H4, C3H4. See this carbon. One, two, three, four. This one, 1, 2, 3, 4. This one, 1, 2, 3, 4. In this complete compound, one triple bond is there. That's why it is unsaturated hydrocarbon. Unsaturated. Saturated means it should only have single bond. Unsaturated means double or triple bonds are there. Double triple bonds are there. Unsaturated hydrocarbon. In hydrocarbons, if the formula is same but the structure is different, formula same, structure different, that kind of hydrocarbons are called as structural isomers. Structural isomers. Same formula, different structure. Structural isomers. Classified into cyclic, acyclic hydrocarbons. These are aromatic or cyclic hydrocarbons, a ringed structure they will be having. Alkane CnH2n plus 2, alkene CnH2n, alkane CnH2n minus 2. In alkane only single bond is present, alkene 1 double bond, alkyne 1 triple bond. Just by seeing the name of the hydrocarbon, you can tell whether it is alkane, alkene, alkyne, or whether it is saturated or unsaturated. If the name ends with ANE, it is saturated, that's it. If it ends with ENE or YNE, then it will be unsaturated, double bond, triple bond. For example, propane and butane are present in LPG. Propane and butane, whether these hydrocarbons are saturated or unsaturated. PROPANE, BUTANE. Both are saturated. ANE ends with, right? Likewise, see the naming. If only one carbon atom is present, we'll call it as methane, methane, methane. Okay, methane only is there because that is the simplest hydrocarbon. Then we have 2 means eth, 3 means prop, 4 means but, 5 pent, hex, hept, penta, hexa, hecta. You will be knowing. Then 8 means octa, 9 means non, 10 means dec. Actually, the important hydrocarbons are these four itself: ethane, propane, butane. Ethane, 2 carbon, propane, 3, butane, 4. That's it. These are the examples for saturated or unsaturated hydrocarbon. See the names. Each and every name ends with A and E, right? All are all are alkanes. Alkanes are saturated hydrocarbons. Alkane. Saturated. Methane found in marshy gas, the gas released in the paddy field. Then, due to bacterial action, also methane gas is released generally. It is generally colorless. Generally, all hydrocarbons are colorless and odorless. For example, in our LPG, propane and butane are present, right? They don't have any smell, any color. But while the gas leaks, we do get a pungent smell, right? Bad odor. That is due to an additive. That additive is extra added for the smell. It will not help in combustion. It will not increase the efficiency of the fuel. It is only there to indicate if there is any gas leak. The additive's name is ethyl mercaptan. Ethyl mercaptan, the additive. Very important thing. Methane is not all hydrocarbons are greenhouse gases. Only methane. Methane is the greenhouse gas. Do you know what the greenhouse effect is? Greenhouse effect. Around our earth, we have atmosphere. We have atmosphere, right? Sunlight. Sunlight comes to us with heat. We do get light and heat from sun, right? In the form of radiation, solar radiation, right? If, for example, you have a sphere of iron, a ball of iron, okay, you are continuously heating it with a flame, lighter. The temperature will increase. It might melt, right, at one point. But likewise, Earth is also continuously getting heat from the sun. If it's night here, the other part of the sphere will be having sunlight, right? Earth, one or the other side, it will be continuously getting lit, continuously, right? Then Earth also should melt, or the temperature should increase enormously, right? But it is not happening. Why? Earth absorbs heat, then it will radiate it back. It will absorb and it will give it back. It will give the heat back. That is the case happening in our Earth. That's why the temperature is normal or in a balanced state. See, which planet is very close to the star sun? In our solar system, there are 8 planets, right? Which planet is very close to sun? Mercury. Mercury. First, Mercury. Second, we have Venus. Next, we have Earth. Later, we have Mars. Then asteroid belt. Later, Jupiter, Saturn, Uranus, Neptune, Uranus. We have, right? Which is the hottest planet in our solar system? Hottest planet. Actually, generally, the object which is close to the heat source will be having higher temperature. That's true, right? The object close to the heat source will be having higher temperature. But here, in the case of our planets, the hottest planet is Venus. Second, Venus, Shukra Graha, is having the highest temperature. The reason is the atmosphere of Venus majorly comprised of carbon dioxide. Atmosphere of Venus is having carbon dioxide majorly. That is the reason, due to the presence of carbon dioxide, global warming is happening there. Temperature is continuously increasing. That is the reason. Here in our Earth, that's why we do talk about controlling the emissions, pollutions to control or maintain the level of carbon dioxide, right? If the carbon dioxide level increases, what will happen? Global warming. Global warming will happen. Global warming happens due to this greenhouse effect. Greenhouse effect means we do get heat in the form of a radiation. Earth radiates this heat back. It will give the heat back in the form of radiation itself, right? What are the greenhouse gases? Name some greenhouse gases. Methane, then carbon dioxide, then. Does water vapor cause greenhouse effect? Water vapor. Will it help in increasing the temperature of the Earth's surface? Generally, today it's very sunny. If you go out and stand in the sun, you might feel little hot, tired, etc. But you're sitting inside, it's pleasant right now, right? If it is cloudy outside, cloudy, you might feel the warmth, humidity, right? You'll be telling, it's too hot today. It might rain in the evening, right? It's cloudy. You feel the warmth here. You'll be telling that it might rain today. Why? What is the reason? Because when the cloud is present, the heat which is trying to escape from the surface of Earth, it is absorbed here. Then the cloud, it gives back the heat to the Earth itself. Cloud absorbs the heat and it will give it back. Greenhouse effect it causes. Similarly, carbon dioxide, CH4, methane, then laughing gas. Laughing gas also causes greenhouse effect. Chemical name of laughing gas? You know laughing gas, right? At least the name laughing gas. If you inhale the laughing gas, you will start to laugh. That's it. Laughing gas. Nitrous oxide, N2O, nitrous oxide. Nitrous oxide. This will also cause the greenhouse effect. Greenhouse effect. Then fluorinated gases, CFC, HCFC, etc., in very minute quantity, they will also cause greenhouse effect. These two majorly contribute for greenhouse effect or the global warming. Okay. CH4, methane, causes greenhouse effect. In the mines, generally methane is released while digging, etc. How natural gas is formed, how coal was formed, how petroleum was formed, how fossil fuels formed. Recently, you might have heard the news that African plate near Madagascar or somewhere, it is breaking apart and it will start to move towards India one fine day. In coming generations, it will come and collide with our Western Ghats, and their Himalayas kind of mountains will be formed in future. It will take huge amount of time, lakhs and lakhs of years, millions of years maybe, who knows, right? How fossil fuels are formed? During this plate movement, while formation of these continents, etc., what happened? The trees, then animals, organisms present on the surface of the earth, they all died and went inside the earth. It was filled with sand, mud, etc. Right? The biomass present beneath, it was filled with soil at high pressure and temperature. Due to the high pressure and temperature, the biomass present beneath converted into coal. It took thousands of years to form coal. That is the reason. That is the reason we call them as non-renewable resources, fossil fuels. Right? Non-renewable resources. They are, if we use and consume them all, they will not be formed in 100 or 200 years. It will take huge amount of time. Right? Fossil fuels, methane, compressed natural gas present above that coal, etc. Methane is also used to produce chloroform. Then it is also used to produce carbon black. Carbon black, a product used in tire industry to give color and printing ink also. Butane. Butane is majorly used in cigarette lighter, and it is also present in LPG, liquefied petroleum gas. Liquefied petroleum gas. Alkene. See, ethene, propene, butene, pentene ends with ene, right? All these are double bond, double bond, double bond, double bond, at least one double bond. Saturated or unsaturated? Unsaturated hydrocarbons, double bond unsaturated hydrocarbons. Examples of ethene, polythene, plastic or etc. Polythene. Then for the manufacture of PVC, polyvinyl chloride also it is used. Alkyne ends with YNE. YNE. At least one triple bond is present. Triple bond, unsaturated hydrocarbon alkyne. In the gas welding, acetylene is used. Acetylene, gas welding. Liquefied petroleum gas LPG. It is not liquid petroleum gas. It is liquefied petroleum gas because gases are converted into liquid form. It is being liquefied, right? How can we convert a gas into liquid? By increasing or decreasing pressure, by increasing or decreasing temperature. You have a quantity of gas with you. Okay, if you want to convert it into liquid form, how can you convert? By increasing temperature or decreasing temperature. If you increase the temperature, the molecules will move away. It will expand. If you decrease the temperature, the molecules will come closer. What will you do now? In the gases, the molecules are already far away. Intermolecular space is very high, right? You will decrease the temperature so that the molecules will come closer. You will decrease the temperature. Then pressure. If you increase the pressure, the molecules will still come closer. Increase in pressure, decrease in temperature, we can convert gas into liquid state. Gas to liquid we can convert. In the cylinder, the fuel is in liquid or gaseous state. In the gas cylinder, LPG cylinder, the fuel is in gaseous or liquid state. Huh? If the cylinder is half filled, when you try to check if gas is still present or not, what will you hear? A liquid moving or what? Liquid moving you will hear, right? Liquefied petroleum gas means the gas is pressurized and stored in the form of liquid. Inside the cylinder, the gas is in the form of liquid. When the nozzle breaks, the pipe breaks, liquid kind of fuel comes out. Just in the open field, if you press open the nozzle, liquid kind of fluid comes out. Later, it suddenly converts into gaseous form, right? Pressurized liquid stored inside the cylinder. Which liquid? LPG, propane and butane. Propane and butane. In summer, butane is more in percentage. In winter, propane will be more in the ratio. Both propane and butane will not have any smell. If the gas leak happens, we cannot know. That's why an additive is added. Ethyl mercaptan. Ethyl mercaptan is added. Ethyl mercaptan. This gives pungent smell. This gives the pungent smell. Ethyl mercaptan, also called as ethan ethiol. Ethan ethiol. Ethyl mercaptan. Ethan ethiol. The chemical which gives pungent smell, bad smell to LPG. Benzene. Have you heard the name? Benzene. C6, H6, benzene. Okay. It's a aromatic hydrocarbon or cyclic hydrocarbon. Aromatic cyclic hydrocarbon. Two, three double bonds are there. This can also be represented simply like this. The benzene ring can be simply written like this. Benzene. Here, 1, 2, 3, 4, 5, 6. C6, H6, benzene. If the aromatic hydrocarbons has the benzene ring, then those aromatic hydrocarbons are called as aryl hydrocarbons or arenes or aromatic hydrocarbons. Other than those hydrocarbons which don't have the benzene ring, they are called as heteroarenes. Heteroarenes. These are arenes used in the manufacturing of plastic, resins, nylon, one of the strongest synthetic fiber, and other synthetic fibers, lubricant, rubber dye, etc. It is used as a raw material. Benzene. DDT. It's also benzene ringed hydrocarbon. DDT. Have you heard the name DDT? Odor, disinfectant to kill ants, etc. Right? DDT. The full form: dichloro diphenyl trichloroethane. Dichloro diphenyl trichloroethane. DDT. Then toluene. Toluene used in the manufacturing of glue, paint, paint thinner, printing, ink, rubber, etc. Then very important thing, it is used to create, manufacture the explosive called TNT, trinitrotoluene. Trinitrotoluene, the explosive TNT. Then naphthalene, insecticide. Insecticide, fumigant. Fumigant means it will create fume, smell. Generally, where do you use naphthalene balls? To get rid of small insects like cockroaches and etc. You do use naphthalene ball in the wardrobe, etc. Right? Naphthalene balls. These naphthalene balls present inside a closed chamber. Closed chamber, they will produce a smell, fume, gas that will avoid the insects. Insecticide, fumigant, naphthalene. It's very poisonous. Please keep it away from the reach of children. Right? Very harmful. Naphthalene. One of my friends during his childhood time ate a naphthalene ball. Later, his body's complete blood was drawn out and new blood was given to him. That much harmful. Just imagine naphthalene ball, right? Correct. Then there are few tests to detect whether the hydrocarbon is saturated or unsaturated. One is Bayer's test, pink to colorless, bromine test, brown to colorless. Here, Bayer's test, Bayer's test. Say recently you might have heard these tests. Tests are also important. Have you discussed about the tests to detect the carbohydrates? You might have. There are few tests to detect the carbohydrates. Recently, in many places, there are so many social media influencer videos regarding fake paneer, right? Fake paneer. Have you seen any video fake paneer? Generally, cost of paneer for 100 grams, let's say, will be around 100, 120, 140 rupees, right? Basic price. But in few shops, it is available for 40, 50, 60 rupees. That is fake paneer, not the original paneer. In many local restaurants, etc., they do use this fake paneer to make the dishes. Where if you eat paneer there, it feels very rubbery, chewy, right? You cannot have it properly, and you will generally know the difference between that paneer and the normal paneer, right? That fake paneer is made by using vegetable oil, fat, dalda, etc., palm oil, etc. It's been made. Normally, the paneer which is extracted from the milk, it will not be having any starch in it. It will not be having any starch. Okay. The paneer which is being produced by the palm oil, other fatty oils, etc., will be having starch in it. Actually, starch is a carbohydrate. Carbohydrates are classified into simple carbohydrate and complex carbohydrate. It's a complex carbohydrate, starch. Starch is generally present in chapati, rice, etc. But this starch is not good for us, right? Fake paneer. That can be detected with the help of a test called as iodine solution test. Iodine solution test. Generally, you get a tincture, right? Tincture, the yellowish solution to clean the wound, right? That is nothing but iodine solution. The easily available tincture in the medical shops can be taken and it can be used to detect whether the paneer is original or fake. If the paneer is original, if the paneer is original, the yellow color tincture, the iodine solution, it will remain yellow. If it is fake, it turns black. The solution turns black. That's a simple test which we all can do. That was very famous recently, few months back. Many McD burger, the paneer present inside it, and various other paneers were tested with the social media influences. But one thing is, already oiled fried paneer, the paneer present inside that paneer pakoda, etc., it will be having starch because it's been fried inside the oil, right? It will be having starch. Testing that paneer will not give the correct result. Testing the raw paneer will give the correct results. Those kind of tests which are in news, right? Likewise, this Bayer's test, potassium permanganate KMnO4, potassium permanganate. This is the solution which we need to test. We are adding, we are adding potassium permanganate. The color turns pink. The test solution, it's pink in color. right? If color remains pink means, if the color remains pink means it is a saturated hydrocarbon, not double bond, not triple bond, saturated hydrocarbon. If it turns transparent with or without the presence of brown precipitate, with or without the presence of brown precipitate, brown color precipitate is formed at the bottom, with or without the presence of brown precipitate, then that can be called as unsaturated hydrocarbon. The test is majorly to test whether the solution is saturated or unsaturated. If it is unsaturated, it returns colorless and gives brown sludge or brown precipitate. If it is not unsaturated, if it is saturated, the color will remain. Pink color will remain. Bayer's test. Bromine test. Here, brown color bromine solution is used. If the color remains brown, then this is saturated. If it goes colorless, then that is unsaturated. That's it. If pink color remains, brown color remains saturated. If it turns to colorless, then that will be unsaturated. That's it. Carbohydrates are classified into, have we discussed? Simple carbohydrate, complex carbohydrate. Classified into simple carbohydrate and complex carbohydrate. Simple and complex carbohydrate. Under simple carbohydrate, we have monosaccharide. Monosaccharide. Only one sugar molecule. Then we have disaccharide. Two monosaccharides combine to form disaccharide. Two monosaccharides combine to form disaccharide. Then under complex carbohydrate, we have polysaccharide. Many sugar molecules combine to form polysaccharide. Many sugar molecules combine to form polysaccharide. Polysaccharide. Under monosaccharide, we have blood sugar. Our blood sugar is, which sugar is present in our blood? Which sugar is present in our blood? Glucose. Blood sugar is glucose. Then we have fruit sugar. Fruit sugar. The sugar present in honey. The sugar present in the fruits. Fructose. RNA full form? Ribonucleic acid. The sugar present is ribose sugar. Ribose. Monosaccharide. Then galactose. Galactose monosaccharide. Many others are also there. These are examples of monosaccharides. Disaccharide means disaccharide. Two monosaccharides combine to form disaccharides. Two monosaccharides combine to form disaccharides. For example, sucrose, the table sugar. Table sugar. Table means the sugar which we use at our home. Sucrose. Sugar present in sugarcane. Sugar present in jaggery. That is sucrose. Then we have lactose. Sugar present in milk, milk products, lactose. Then we have maltose. Sugar present in potato. Sugar present in wheat, barley. Sugar present in beer, whiskey, brandy. Maltose. Have you heard the name single malt whiskey, double malt? Maltose sugar is present there. Maltose sugar is present in that. By the fermentation of grains only, the whiskey, etc. are formed, right? Maltose sugar is present. Disaccharide means two monosaccharides are combined. In sucrose, GF glucose plus fructose combine to form sucrose, lactose, glucose plus galactose combine to form lactose, maltose, glucose plus glucose only, glucose plus glucose, maltose, glucose plus glucose, maltose. Under polysaccharides we have animal cells don't have cell wall, they only have cell membrane. Plant cells do have cell membrane and also cell wall. Cell wall is made up of complex carbohydrate called cellulose. Plant's cell wall is made up of cellulose. When we have fruits, vegetables, cereals, grains, the cell wall content cellulose we do consume, right? While consuming all these carbohydrates, we get energy, but we don't have the ability to get energy from cellulose. By having greens, fruits, vegetables, the cellulose present in it, we cannot get energy from it. Then we do use cellulose in the form of fiber, roughages. In the form of fiber, roughages, we do use cellulose as. Then we have glycogen. Then we have starch. Starch. Glucose is converted to the form of glycogen and stored in where? Today you are fasting. Let's let's assume. Yesterday you had so much food. The sugar present in the sugar which was present in your blood, it was converted to glycogen. Temporary conversion in the form of glycogen with the help of the hormone called insulin. Insulin maintains blood sugar. Insulin it converted the glucose into glycogen, and glycogen is stored in our liver and muscle. In our liver and muscle. Right? Today you are fasting. You need energy. That energy, in the first case, you will get from the liver and muscle, which was stored in the form of glycogen. That glycogen will be converted back to the form of glucose with the help of a hormone called glucagon. Glucagon. That is also produced by our pancreas, where our insulin was produced. Right? The process of converting glucose into glycogen and glycogen back to glucose, this cycle is called as glycogenesis. This process. Glycogen, complex carbohydrate, then starch, complex carbohydrate. Honey, fruits, fructose, blood sugar, glucose, RNA, ribose, galactose in milk product, sucrose, table sugar, sugarcane, jaggery, lactose, milk product, maltose, beer, potato, grains, etc. Cellulose, cell wall of the plant cell, glycogen, stored in our body, glucose, starch, the complex nutrient, right? Among all these carbohydrates are generally sweet in taste, right? Which is more sweeter? Sweetest sugar, sweetest natural sugar. See, assume, leave the complex carbohydrates, they're not that sweet when compared to the monosaccharide and disaccharide. Assume you are having a spoon of sugar, you are having spoon of milk, you are having spoon of potato or wheat, you are having a spoon of glucose, spoon of honey, spoon of nothing, spoon of any milk product, which you will feel more sweeter? Milk? No. Wheat? No. Fruit? Depends. Honey? Yes. Sugar? Yes. When compared to sugar and honey, which is more sweeter? A spoon of sugar, a spoon of honey, which feels more sweeter? Obviously, honey. Honey is more sweeter when compared to the normal sugar, right? Glucose, no, less sweeter. We might have thought in our childhood while consuming glucose, right? It's just like a sugar powder, but it's not. It's completely different. The composition is completely different. When an athlete requires energy instantly, what he should consume? That's in examination. When an athlete requires instant energy, what he should consume? He should consume glucose because the blood sugar is glucose. If you eat any other food, banana, fruit, vegetable, etc., it takes time to convert to that form. If you directly consume glucose, you will get energy instantly. By consuming it will take time. That's why when you are sick, they will directly give glucose to your veins, directly to the bloodstream, so that you will get instant energy. That's it. Sweetest natural sugar, fructose. Then we have sugar-free naturals, etc. Right? Hmm? The tablets sugar patients used to take, sugar-free naturals. Then sugar-free ice cream, sugar-free sweets. They are sweet in taste, but they are costly. They don't have any calories. Zero calorie product. How? There are so many synthetic sweeteners, synthetic artificial sweeteners. They give sweet taste. They give sweet taste, but they are not carbohydrates. They don't have any calories or they don't give us any energy. Example, sucralose, saccharin, aspartame, astatine, etc. These are all the examples of synthetic, artificial sweetness. Then, very important, test to detect these carbohydrates. The important test to detect the paneer, whether it is original or fake, that is iodine solution test. Iodine solution test. Iodine solution test. Yellow color iodine solution turns to which color? Turns to blue black color, dark black or blue black color. You can just Google fake paneer test in YouTube, Instagram. You will get a number of videos. A number of videos. Iodine solution test to detect the presence of starch. Test to detect starch. Iodine solution test. If starch is present, it will turn to blue black color. If starch is absent, the color remains yellow. In the normal original paneer, starch is not there. In the fake paneer, starch is there. Then test for glucose. Test for glucose to detect the presence of glucose. We have Benedict's reagent test. Benedict's reagent test. Benedict's reagent test. Test for glucose. Copper sulfate plus tartaric acid plus sodium hydroxide solution. Copper sulfate is the major ingredient. Here, blue color solution turns to blue color solution gives a brick red precipitate. Brick red precipitate. Precipitate means what? Powder like thing comes and settles at the bottom. That's it. Brick red precipitate is formed to detect the presence of glucose. Then test to detect the protein. We have biuret test. Same copper sulfate solution. Blue color solution turns purple or violet. Blue color solution turns purple or violet. This test is important because it is in news. Do you know the process of manufacturing rubber? Rubber manufacturing process. How how do we get rubber? Tree. Have you seen the rubber tree? Bark of the rubber tree. It's being grooved and a container, a cup-like structure. Earlier, it was the coconut shell was used. Right now, plastic cups are being used, and small drops of whitish thick fluid rubber comes out from the rubber tree, and it's being stored in that container. Later, all the rubber being collected and it's being processed. The processing of rubber from the natural form to the commercial form, that is called as vulcanization. Vulcanization. During the time of vulcanization, sulfur is being used. What chemical is being used for the vulcanization of rubber means sulfur. Sulfur is being used. Then the natural form of the rubber's monomer. The rubber's monomer means a simpler form. That's it. The simpler, basic chemical form of the rubber, that is isoprene. 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 Then the basic before vulcanization form of rubber is called as latex. A rubber's pre-processed form. In your mattress, etc., you might have heard about a layer called latex gel, right? That is the first starting phase of the rubber, latex. Then after vulcanization, we do get rubber which is ready to use in the commercial form, tire tube, etc., that can be manufactured from it. Vulcanization is done by sulfur. The natural rubber's monomer is isoprene. Then the initial form of rubber is latex. That's it. Synthetic materials. Name some natural fibers. Jute, cotton, wool, then coir, then silk, right? Natural fibers means extracted from the nature directly, from animals, plants, etc., right? Silk extracted from silkworm. Do you know the lifespan or the life cycle of the silkworm? Do you know? Have you seen the silk cocoon? You are ready from? Means have you seen the complete process how the silk? Okay, that's good. You might have seen the poultry farm where the poultry farmers get hatched chickens from the supplier. They will just give them food, medicine, etc., and make them grow. Later they will sell them. That's their part of job, poultry farmers job, right? They will not do the hatching, they will not do any other thing. Here also the silk farmer's job is to take the eggs, They will get the eggs, not exactly on the leaves, different paper kind of sheet. They will buy the eggs, then they will give them the suitable environment, enclosed room with some high temperature, maintained room temperature. Later, the eggs will hatch. Once the egg hatches, larva larva comes out. Earthworm kind of larva, small larva comes out. Later, it will start to feed on mulberry leaves. It will be fed with mulberry leaves, Hipponerida soup, continuously. After a few days, 1 or 2 weeks, it will be grown to the fuller size. The fuller, bigger size called pupa. Larva to developed pupa stage. In the pupa stage, what it will do? It will stop eating one fine day. Once it stops eating, it will secrete a liquid from its mouth and it will move its head body in the shape of 8 like this. It starts to move. By doing this, it will create a web around its body. You might have seen small worms. What do we call? Erehula, Kambli hula, right? Converting it to the butterfly, caterpillar to butterfly. You might have seen, right? Similarly, similar case here. What happens here? It will create a cocoon. Cocoon means complete shell-like structure made up of the silk fiber. Spider web is chemically a protein. Chemically, spider web is a protein. How spider web is formed? You might have seen. You might have observed. Have you observed how the spider forms its web? It will secrete a liquid. When that minute liquid comes in contact with the air, it turns into a fiber. The liquid turns into fiber. Here also, it secretes a liquid. When liquid comes in contact with the air, it turns into fiber, silk fiber. It creates that web around it, cocoon. It's hidden inside. That's why the operation of Virappan, capturing Virappan, encountering Virappan, it is called as Operation Cocoon. Why? Inside that ambulance, enclosed from everywhere, he was being killed, right? Likewise, here, the silkworm will be killed when it is inside that cocoon. During the pupa stage, the silkworm is present inside this cocoon. The farmers will sell this silk cocoon. Farmers will sell this cocoon. Reshma Gudu, they will sell. Then later there will be so many industries where separating, extracting the fibers from this silk cocoon will happen. Before that, the worm present inside that cocoon will be killed by placing it under the sun or with the help of steam, extreme temperature, etc. The worm will be killed. Once it is killed, later the silk fiber will be extracted. Silk fiber will be extracted and cloths, etc. are made. If the worm remains alive inside that cocoon, it will come out by breaking the cocoon in the form of adult moth. Later, that adult moth will lay eggs. The cycle completes, but this thing will not happen with the case of the silk farmers. What they will do? They will purchase the eggs. They will sell the cocoon. This is their life cycle. Silk fiber naturally is protein. It's a protein. 80% fibroin protein, then 20% sericin protein. Sericin. The silky, shiny outer layer sericin, inner strength layer fibroin. It forms the silk fiber. It's a natural fiber. Natural fiber. Silk fiber. History classes start ಆಯ್ತಾ? Not yet. When did Gandhiji come to India? Yes. Later, the first protest he joined was where? Before that, Gandhiji came to India. Then he thought, will get completely involved in this independence movement under the guidance of his leader, his guru, Sri Gopalakrishna Gokhale. Gandhiji started his journey with Indian independence movement by starting his first protest in Champaran. Have you heard about the Champaran movement? Champaran. In Champaran region in Bihar, he started a protest with the indigo farmers. Indigo farmers. Indigo is a color, right? Indigo color. Earlier, only natural coloring element dyes were present, no synthetic chemicals were present. To color the textile, to color the cloths, the indigo was used. Britishers encouraged Indian farmers to shift from the natural cultivation which were doing and starts to cultivate indigo for their requirement. When huge amount of farmers have grown the indigo, during that time what happened in Britain, they have developed a synthetic dye, synthetic chemical which gives color. These indigo farmers didn't get the required amount of money, etc. That's why they started to protest. The first protest Gandhiji involved in. Likewise, we have cotton. How much time does cotton take? Months and months of time for it to get developed, then extraction, then processing. The difficulty or the problem when compared to the cotton shirt, the cotton cloth, and the normal synthetic cloth, cotton difficult to maintain. It will be shrunken very easily, difficult to maintain one thing. Then durability is also less compared to synthetic material, cost high compared to synthetic material. All these disadvantages were there, right? Then is it possible to fulfill the demand only by natural fibers? Not at all possible. Fulfilling the demand. That's why synthetic fibers came into the picture. Synthetic fibers. First synthetic fiber, one of the first synthetic fibers, nylon, one of the strongest synthetic fibers also, one of the strongest synthetic fiber. Nylon is being used in the manufacturing of rope, sleeping bag, parachute, cloths, etc. Nylon. The monomers of nylon, very important. Nylon's monomer. Monomer means the simplest basic structural unit. Many monomers combine to form a polymer. All synthetic All synthetic materials or polymers are made up of many monomers. The monomer of nylon is adipic acid and hexamethylene diamine. Adipic acid and hexamethylene diamine. Monomers of nylon, one of the strongest synthetic fiber, nylon. Generally, what is the cost of a pure Mysore silk sari or Mysore silk dhoti? 15, 20,000, 30,000, at least 20,000 and above, pure. But semi, crepe, etc., Mysore silk saris are available for 800,000, 2,000 rupees. That's not original at all. Semi will be around 10, 15,000 rupees. Semi means some amount of pure silks, natural silk, some amount of artificial silk fibers are used. But complete artificial fiber will be of less cost, similar appearance, not exactly the same appearance, similar appearance, right? Rayon X, it is a semi-synthetic fiber, semi-synthetic, developed, extracted from the wood pulp as well as by using chemicals. Rayon's monomer is cellulose. It is called as artificial silk rayon, alternative to the natural silk, artificial silk rayon. Nylon, one of the strongest synthetic fibers. Then we have polyester. Its monomer is ester, polyester, making dress materials, etc. Polyester cloths. They are wrinkle-free, durable, washable, less costly. Terling, it's a known example of the polyester. Example of polyester. Then have you heard the name bottle? Pet bottle. Pet bottle is not the bottle which you carry along. Pet bottle means it is made up of a chemical called polyethylene terephthalate. Polyethylene terephthalate. The bottles, plastic utensils, plastic boxes, etc. are made up of a chemical called polyethylene PET. Then have you heard of BPA free? BPA. Have you heard? Tupperware company, you remember, right? Plastic bottles, containers, etc. Those kind of quality plastic reusable material will not be having this chemical. In those kind of costly plastic utensils or containers, in the box itself, it will be written BPA free. BPA is a chemical. BPA is a chemical which is generally used in use and throw storage plastic containers. The basic cheap plastic containers, BPA is used. In the reusable containers, it is not used. BPA is a chemical. Bisphenol A. Bisphenol A. It's not used in the reusable plastic containers, reusable containers. Then we have acrylic, alternative to the natural wool. Alternative material to the natural wool, acrylic. See, why it feels warmer when you wear woolen cloth? Will it increase the body temperature? By wearing woolen cloth, will it increase your body temperature? Yes or no? No, it will not. What is your average body temperature? Hmm? 0 degrees Celsius freezing point of water, 100 degrees Celsius boiling point of water. Actually, you're nearby to the value 98.6. It's degree Fahrenheit. 98.6 degree Fahrenheit. Average human body temperature. Or we can say 37 degrees Celsius. Average human body temperature. See, In many examinations, they have asked this concept why wearing woolen cloths keep us warm in the winter. The reason is, see, wool, the woolen fibers, they're arranged somewhat like this, right? Air will be locked between these fibers, air, air packets. Air is a good conductor or bad conductor of heat. Air, water and air are bad conductors of heat or poor conductors of heat. Yes, air will be heated, but it heats up slowly, cools down slowly. If any material heats up faster, cools down faster, then that is a good conductor. If heats up slowly, cools down slowly, then that is a bad conductor. Bad conductor. Here, air locked in between the fibers acts as a insulating layer. Acts as a insulating layer. So wearing a woolen cloth feels like a insulating layer. Your body temperature will not go out. Your body's temperature will not go out. The outer lower temperature will not affect you. Outer temperature, let's say it's 15 degrees Celsius, it will not affect your body. That's why you feel warmer. Why warmer? Your body temperature is 37. Outside temperature is 15. The 15 degree is not affecting you. Your body heat is not going outside. That's why you feel warmer. Cool, insulating layer. Instead of wearing a single thick shirt, wearing two thin shirts keeps us warmer. Why? Because in between those two thin shirts, the air layer will be there, right? Air. That air will act as an insulating layer. That air will act as insulating layer. That will keep us warmer. That will keep us warmer, right? Like this, many application-based questions will come in one examination. Summer, winter. From the same spot, you are getting water. Okay. The water which is coming out from the hand rig, it feels colder here. It feels warmer here. They have asked the reason. One option, during the winter season, the water feels warmer because due to the friction of the borewell rig, the temperature increases, they have given. First option. Is that right or wrong? 100% wrong. Due to the friction, the temperature will not, it is not rising. Then the second option, during the winter time, the water feels warmer because the cooler water from inside comes out and absorbs the heat from the surrounding atmosphere and it feels warmer, they have given. The water was cool, which was present inside the earth. When it comes out, it absorbs the heat and it feels warmer, you have given. Right or wrong? Need some brainstorming. Okay. Then later they have given. Actually, the temperature inside the earth during both the seasons in the same point is same. During both the seasons, the temperature of water inside is same at that point. But during the summertime, the atmospheric temperature is more. That's why it feels colder. During the winter, the atmospheric temperature is less. That's why it feels warmer. Right? Yes, that is the yes, that is the answer. See, for example, let's say at this point the water temperature is let's say 15 degrees Celsius. 15 degrees Celsius. During summertime, the temperature is 40 degrees Celsius. It feels colder, right? During winter, let's say the temperature is 2 degrees Celsius. This feels warmer, right? That's There will be at least one question like this in the examination where you need to think. Critical thinking required. You need to observe what they are trying to ask. Okay. Assume you are traveling in a train. You are traveling in a train. The train is moving with the speed of 110 kilometer per hour. 110 kilometer per hour. The train is moving. You are sitting in the train. You have thrown a ball into the air. Ball into the air. Okay. The answers are: the ball falls directly to your hand. The ball falls behind you. The ball falls in front of you. These three options. What you will choose? You are traveling in a train. You just popped a ball above. Will it fall to your hand, behind you, in front of you? What will happen? Practically, think. Theoretically, you are thinking. You're moving in a car, 160 kilometer per hour. Moving in a train, 110 kilometer per hour. If you throw apple ball above, will it fall behind you? It will come to your hand, right? What we generally do, or a question being asked in a examination like this, there might be some twist. We'll start to think extra. That's why the simpler questions will become difficult. The momentum of the ball will be the same as yours, right? You are also moving, the ball is also moving. The speed by which you move, the ball will also move. The ball will fall to your hand itself. That's it. It will not go behind or further. Like this, they will ask the questions. If you drop two objects, mobile phone, pen, from here, which will fall to the ground first? Which will reach the ground first? Heavier mobile phone. Here, in the moon, let's say, a small stone, a big rock, which will fall to the ground first? In the moon, it will fall. For example, Neil Armstrong will be moon walking on the surface, right? There is gravity, but there is less gravity. Gravity is less, but gravity is there, right? Both will fall at the same time, free fall, because no opposite retaliation force is there. In our earth, air is there. It will act some opposite retaliation force, right? There, nothing like that is there. That is the case. Okay. Okay. Let's end here today. Tomorrow we'll discuss the syllabus, complete examination syllabus, pattern, etc. Then we'll discuss the previous year questions. Then we'll start with the topic. From tomorrow, try not to miss the class. Okay. If there is any emergency or if you have any other classes, at least try to cover the classes by seeing the recorded videos. Okay. Important classes will be there. Try not to miss. Okay. Thank you. The wall is also not with us, right? The wall is not subject to back. How? the momentum in the ball and the momentum in you and the momentum. See, if you jump in that train, will go behind. Not it. Will still slap. That same case here also. That's
No, it is not safe. Today only. 10 minutes.